This is tutorial 8A question 6, and we're going to do question 6D. We're given the equation describing a complex sequence xn. So this is not a real vector anymore, this is a complex vector where little n goes from 0 to big N minus 1, and we are given n is equals to 16. Right, so now what is xk? And of course, if we have done it in brute force, we'll construct xn and then using the DFT analysis equation to find xk. But in this answer, we're going to do it more simply by inspection. So this is the slide for the answer, and here is the strategy to answer the question. So basically, in this question, we can match the coefficients of the IDFT equation to the equation representing xn. What am I talking about? This is the equation representing xn. And then we know that we can represent xn by the IDFT equation, which is this guy. And later on, you will see that when we match the equations, we can find the coefficients xk. Okay, that is the strategy. So what should we do? Well, let's open up this equation xn first. So we have 3e j 2 pi over 16n plus pi over 3. So this is the equation. We can write it in as a sequence multiplied by a constant. So 3e plus j pi 3 is this value here. I should use pink. And of course, the other member is this guy, which is this guy. So I can break the complex exponential into product of two complex exponential, and this is a constant. So I can write the constant outside here, and I can write the sequence as a vector, which is 2 pi over 16 times n for n equals to 0 to 15. So we call this equation A. Now, this should be very familiar to you. This sequence is a complex exponential which also exists in WH. Where exactly it is? Okay, let's find. Alright, so once we can find that this sequence belongs to WH, then isn't this coefficients the one we want? Alright, let's go through to find what is IDFT equation. IDFT equation is 1 over big N WHXK. Let's expand the WH as column 0, column 1, column until 15. So it's 0 to 15. So across here it is K. Now let's observe what each element of each column is. Let's go to the WH matrix, and we find that it is described by this notation. Every element of the WH is simply E plus. Okay, this is the important one. 2 pi over n kn. If you forget, let's go and see our slides. So again, this is a slide showing the DFT synthesis equation who have xn 1 over n. This is WH here, WH, and the elements of WH is E plus J 2 pi over n kn. Alright, once we have this equation here, all we need to do is to fill up the columns. Now, by the inspection of the equation A, we need the columns EJ 2 pi over 16n. Therefore, K is equals to 1. So we are interested in when K is equals to 1, 2 pi over 16. Then the varying n over here. So we can write here as the column 1 of WH. The coefficients is 3 EJ 2 pi over 3. We bring it here. The column is here. and then we are writing the equation now. So when we write the equation, what we can do is that we can then recognize this equation as the constant x1 multiplied by this column. Okay, but actually it's not exactly x1, it is 1 over n x1, which is what we need, multiplying by this column. And therefore, we now know that x1 is simply n times the coefficients that is outside. And since we have already described xn using this equation, the rest of the x, for x0, x2 until x15, all these values are 0, the big X. Okay, that's it for this equation to find xn by inspection of the inverse DFT equation. Thank you.